So in this video, we are going to discuss about the classifications of analog to digital converters. So the classifications can be done based on their operational features. First, let us discuss about the type 1. So this type 1 is classified into two groups. One is programmable ADC and another one is non-programmable ADC. So in the programmable ADC means here this analog to digital conversion is made in a fixed number of steps with equal time interval. Suppose if you see the successive approximation technique, SAC, okay. So the detailed video regarding the uh, successive approximation technique is given in the description box. You can verify that one. So this is it will take a fixed number of steps with equal time interval in order to convert my analog signal into a digital value. So it is irrespective of the analog input signal. Okay. So this is an example for a programmable ADC. So next type 2. So the type 2 is non-programmable ADC. In the type 1, sorry, in the type 1, B is non-programmable ADC. So it requires a sequence of steps initially. Okay. And time interval of the sequence of steps. Which depends only on the response time of the conversion circuitry. So if you see the example called single stop or dual stop, so this both will comes under integrating type because here there is integrator. So if you see the dual scope ADC, initially whatever the input, it will take initial steps, that is a time interval sequence of steps which depends on the response time, that is which is depends upon the reference input of the conversion circuit. So the next let me go for the type 2. Okay. So here also it is categorized into two types. For the first one is closed loop. So the closed loop is called as feedback type, right? So the feedback type ADC. So the feedback type ADC is here the analog voltage generated internally as a function of digital input is fed back to one of the input of the comparator, and this voltage with analog voltage under conversion. So this voltage is compared with the analog voltage under the conversion. So whenever the input voltage and the feedback voltages are equal, the conversion is complete. So the DAC based ADC conversion belong to this category. Okay. So since it is a closed loop, there is feedback type ADC, so it requires a DAC. So which and all it will require a DAC. For example, the successive approximation technique also it has having a DAC, right? And you can see the counter type ADC also it is having a DAC, right? So here the analog voltage which is generated internally as a function of digital input is fed back to one of the input of the comparator. So this voltage is compared with the analog voltage under conversions. Okay, so whenever the input voltage and the feedback voltage are equal, the conversion is completed. So I think so the counter type and servo or tracking type um, ADC will comes under this category. Okay, so where there is a my analog input and this output from the DAC. Okay, is compared. So whenever this is equal, it will get stopped. Okay, so such type of comparator something analog to digital converters comes under this category. So the next one is open loop. So here the open loop or non-feedback type ADC. So here the direct comparison is made. Okay, direct comparison is made. So there is no requirement of DAC. Okay, so there is a direct requirement with comparison is made between my input voltage and reference voltage. Okay, so such type of ADC is nothing but flash ADC, right? So based on the result of this comparator, digital output is obtained. Okay, so next one is type 3. So the type 3 also it is categorized into two type. One is capacitor charging type, ADC, and discrete. Second one is discrete voltage comparison type ADC. So here the capacitor type ADC which will operate on the principle of charging the capacitor at the rate of the input voltage. So while simultaneously pulling out the discrete charge packets out of the capacitor at the rate at which the net charge flowing is always zero. So this capacitor balancing integrated type of ADC belong to this category, right? So single slope ADC, single and DO slope ADC will come under this category. So the discrete voltage comparison type which will employ the principle of generation of discrete voltage, okay, whose level are equivalent to the digital words. So this comparison of these discrete voltage level is then made with the analog input voltage to determine the equivalent digital word. Yeah. So the weighted capacitor, weighted capacitor of DAC will fall under this category. Okay. So the next one is type 4. So here also there's two types. One is direct type, another one is integrating type. So the direct type will compare the analog input with the internally generated equivalent analog value. So I compare my V in, that is my analog signal with internet generated equivalent. I don't know what's the. So the example of this type is flash. Next one is counter type, and then one is tracking type. SCAC, that is successive approximation technique, comes under the direct type ADC. So the integrated type will perform this analog to conversion in an indirect manner. Okay, so this is a special case of converters, so which will uses either a reference voltage or integrate the signal during the conversion purposes. Therefore, it will not require any sample and hold circuit at the input. So this process of integrating the signal, also integrating the ADC, are suitable for a very low frequency signals. Okay. So many of the digital voltmeter will employ this integrating type ADC in the circuit. The charge balancing type and dual slope ADC will fall under this category. Okay, so the integrating type ADC is comes under dual slope ADC.